Alright, so a few evenings have passed and even half a summer, but this has managed to fuck itself up again. And having a look, we can see that bank 8 or 9 if you start counting with 1. Right, the second to last bank really not doing fine. Right, so the pack is now at 100%. The BMS stopped the charging, and this second to last bank is at 3.6, so it's below 3.7, meaning it's below 50% charge. Man, I would basically expect 40% charge in this bank. And what this means is you basically have 40% of the entire pack, right? Because this will hit 3 the first, kind of. And then the BMS will cut power completely, right? So yeah, half the range, not great, right? Not great. But yeah, how many kilometers does this have? 3,000, not bad. 1.5 years, 3,000, not too bad. Anyways, so I'll get this on the bench and we'll go from there. All right, and the last step is to simply disconnect. So the battery LED is actually solid blue, which might mean it's balancing, but yeah, screw that. It might actually be debalancing the pack, as far as we know. But we'll open it and have an actual proper look at it. Okay. Actually, one more thing that needs to be disconnected is the brake light wire, which passes through the entire battery. This is not too fiddly, so that being said, I think we may head on over to the bench. Alright, so we're back on the bench. And yeah, so hopefully this time around it's gonna be a bit easier to undo everything. So far so good. These have been quite the pain in the ass last time, but yeah, now they even seem to be a bit undone. So alright, so let's see how strong my silicone is when compared to what Xiaomi had on here. I'm hoping not very, but I'm a bit worried. I'll say this much. Let's first go in with the small shit. This is not looking good. Or, yeah, I guess this is doable. Let's see. So last time I think I got this cool idea. And given that this pack is seriously unhealthy, I'm actually considering not gluing this back up because yeah, how much water is gonna get in here. I've been through quite a bit of rain with the scooter and didn't get any serious ingression in here. So, but yeah, I'll have to let my future self decide that, because at the moment I'm quite preoccupied with getting this off without breaking the seal here, right? So I've thought about this, and I don't think last time I had to. Holy shit. All right. Yeah, I almost dropped this on the floor. Yeah, this is going pretty well. Yeah, I'm quite happy. All right. Yeah, this was somewhere around 5 to 10 orders of magnitude less work than last time. Right, so I'll link the video up here so you can have a look at my first attempt, which is not very visible, but once we take this off, it would become quite apparent. Anyhow, so the boards are on this side. This can actually stay attached. And last I saw a BMS stay firm on, right, like a solid blue. It was actually trying to balance its cells. The last one that was doing this was wrongly doing so, but anyway, this case does warrant some balancing, we'll say. Anyhow, so second to last bank. All right. Let's have a quick measure and see what we're up against. And if it is indeed unbalanced, I will take a significantly different approach from last time. Last time I actually replaced four entire cells, right? So an entire bank. I don't remember exactly which one it was, but again, the video up top should go over all of that. And I don't think that did the trick, right? I don't think that was the cause, right? So I'm now suspecting, given that the readings are fine, it's not the balance caps. The BMS chip on these has actually one balancing wire going towards each bank, and those actually have some capacitors on them, which I've oftentimes seen fail. Now you can see that those have failed in that one cell's voltage will be lower and the next adjacent one will read higher, right? Suggesting that one of these caps is leaking. I actually do have a video going over that as well, but you can't see that here, right? And what they have extra, as opposed to the regular M365 battery, which they use on the Mi 3 and the 1S, are these chips here. And these are actually, I'll put the data sheet up on the left. These are over voltage chips, and I'm thinking maybe somehow those end the charge for a specific bank sooner or do something. I don't know. I really don't know what's going on. That's just a hypothesis, and I'm almost sure it's wrong, but or something is off in the BMS, right? Which is a pain in the ass to change. It's very hard to find original parts, and if you get shit from China, they send it with no fuse. I don't know, it's a pain in the ass. I don't want to go there. So anyway, this measurement, the numbering here starts with 0, so we would expect this to be the problem, and it is, right? Fuck. All right. So all the other banks, let's just go over them, should be full. And they're even a bit over full because probably the BMS ends the charge a bit later to attempt to put more juice into these, but at some point these get to close to 4.2 and it just quits. Usually it likes to keep cells at 4.1, which is very nice of them. Should prolong the life of these tremendously. So anyway, first bank, second bank, third bank, fourth, fifth, and you can start seeing my work here. Fifth, sixth, seventh, eighth, ninth, and 10th. All right, so in this case, I am not gonna give a fuck, basically, in a nutshell, and I'll just attempt to externally charge the offending bank and see what happens afterwards, right? I want to charge it to 4.2, so above what the rest are at, and I'll just ride the scooter more and see if it decides to kill a random different bank, then it is the BMS. If this keeps dying again, it means that replacing the offending bank the first time was worthwhile and should be done in this case as well. And I maybe have a fucked up batch of, these are LG MH1s. You can see it over here. So technically good cells, but yeah, shit happens. I don't know. Maybe I got a bad batch. And I am riding 1000 watts instead of 500, right? So should still not be that much current per bank, but anyway. So they have these jumpers, which are very nice and convenient to solder to. And I think we're talking about these. All right, and that is the case. Let's mark their polarity because I don't want to fuck up my charger. All right. So this would be minus, and this would be plus. And because I'm an idiot, I'm going to check that again. And also check that the leads are properly inserted, because I actually did manage to once fuck that up as well, and yeah, that was pretty bad. Anyway, 3.6, that's fine. Let's just get some bits of wire onto there and get the charging. So TS80 with Ralim's custom firmware, obviously, and bits of wire. So this seems decent, and this, okay. The offending bank is connected to these wires. Let us one last time measure the polarity, because I'm in no mood for fuck-ups. Yeah, anyway, so that looks fine. And what I feel like doing is initially discharging this completely via a TP4056 module, which will protect the cell, right, which will end the discharge. The fact that there are so many screwdrivers on here is stressing me out a bit, so let me clear the table real quick. Okay, what do we need? So I'll want my Croc Clips XT60 interconnect adapter. All right, let's put this into the meter. Unfortunately, I want to use this meter the wrong way, which will require 2 throughs. So in this case, male to male, and we should get some voltage, or it should explode. All right. How fortuitous. Okay, let's reset the values. 3.6, I'm expecting what? So these full should be like 4 times, what were they? About 10,000 milliamp hours, I think. I'm not sure. I'll just put up some card here. But anyway, I'll terminate this into a USB connector so we can use this load. And I'll gently lift this up. 600 milliamp hour, 600 milliamps divided by 4. That's what? About 150 per cell, so that should be fine. Should slowly discharge these, and I think I will not record this draining, or will I? I'll probably do a time lapse. Who knows? We'll see. Meanwhile, these have finished discharging and clocked in at 3,900. So just to be super pedantic, let's go for 3,897 divided by 4. So these had about 970 milliamp hours left per cell, right? And so next step is to reverse the setup and actually charge this bank up to 4.2. And yeah, we'll go from there. Evening. Yeah, the wide sucks on this. Anyway, so today's the day after tomorrow. I don't know. Is there a word for that? Most likely not. Anyway, so this has been going. I've disconnected it for safety reasons because I don't know. This is going through my equipment, which I definitely do not trust. Anyway, we have about 12,300 milliamp hours having flown into these cells, and they're charged, I think, ever so slightly above the other ones. Let's check right quick. I'm doing a super good job of this. 4.16, 4.15, I don't know, yeah, thereabouts. 105 anyway, ever so slightly above the rest of the pack. So what does that give us? So 12,345 divided by 4 is exactly 3.1 amp hours, which these are rated at 3.2 amp hours. Again, I'll put the data sheet on the right side. So we would have to do, what do we have to do? So this, I don't know what the exact order of operations is because I'm an idiot, divided by 3.2 thousand. And this should give us how much percentage of the expected capacity these still hold from 0 to 1. 96.44%. So yeah, I don't know. This should have been the case with this as well. So yeah, I'm not going to change these right now because it's a pain in the ass. You have to undo everything. It's super disastrous. The worst pack to change, I think, will be this. But either one of these. But anyway, this is pretty bad as well. Definitely, I've charged it at 1 amp. And I've not discharged it at, what is it, like 30 amps per bank. Or 35 amps per bank. I don't know what exactly I'm running these at. So there might still be internal resistance issues and stuff like that that would cause this to fail in situ, kind of, right, in production, so to say. But if it fails again, right, if it goes under voltage, if it lags behind the rest of the pack again, we'll open it again and I'll have a part 3 on this. But given that it's a different one, I really am not expecting these to fail at this rate, right? And given that I'm pulling, let's go 30, I think I'm doing 38 amps, right? Divided by 4, what is that? 10 amps, right? It's a lot, right? It's 10 amps is no joke, but these are LG cells, right? LG MH1s. It should be fine, right? I don't know what the rated discharge of these is, but I mean, you can abuse them ever so slightly. I don't know. So yeah, I'm gonna put this back together now and maybe leave it in the comments if this has fixed the issue. And technically it didn't fix the issue, it covered up the results of the issue, right? I again suspect the overvoltage chips to be at fault and to perhaps stop charge prematurely on random cells. I don't know. Absolutely no idea. Let's turn more lights on. But yeah, given that the pack's now balanced, I can reconnect the balancing wires. Really hope there's no order to this, because it would be very damn sad if I'd have to replace the BMS, because it's still a pain in the ass to find original parts. So yeah. Alright, is the LED blinking? Because it kind of should start blinking. Where's the LED? You know what, it is not blinking. Let's try and gently press the button. Try and reset it. Alright, so it's now alive. Which is good, which is not the worst outcome. Let's turn this off. And I think next step would be removing these wires. And keep in mind, these are actually jumpers. So they're marked as such, right? JP9, JP8. You can't actually disconnect these. I think they're using that in production somehow. So right now I have disconnected this one. Let's give it a bit more juice. All right. Same here. And yeah, that's fine. I'd call that good enough. Is there anything else I have to keep in mind? I don't think so. All right. To whatever the fuck that was before. Yeah, so next up, we'll connect this to the scooter and have a look on M365 tools. Check to see if the computer also sees, the BMS also sees the problem as solved. All right, and we can probably go ahead and connect to it, hit the headlight. Alright, so battery looks full, and 58 millivolts. Yeah, probably I worked on bank 8, and it's now up at the top, but it is slightly unbalanced. But again, nothing too serious, I'd say. So, but yeah, anyway, that's been it for this video. If you have any questions, or actually more importantly, if you have any suggestions for what I should do going forward, please let me know. I'd be very curious to hear your input on this. But yeah, have a good one.